On January 30th, 2000, a dam in a mining facility holding water contaminated with cyanide burst, releasing its contents into farmlands and into the Someș River in Romania, which is a tributary of the Tisza River. The contents of the contaminated water held by the dam included an estimated 100 metric tons of cyanide. This cyanide wiped out almost all life, from microbes to fish to mammals, in a stretch of the Tisza River, according to the BBC. As the Tisza River flows through several countries and is a tributary of the Danube River, the effects of this cyanide spill reached over 1,000 kilometers and contaminated the drinking water of 2.5 million people in Romania, Hungary, and Serbia. Furthermore, 15,000 individuals who relied on fishing as a means of living saw their profession temporarily wiped out overnight. This has been described by some as the worst environmental disaster in Europe since the Chernobyl nuclear accident in 1986. So how did this happen? Why did the water held by the dam have such a high concentration of cyanide? In this video, I will describe the Tisza River ecosystem, the damage done to the ecosystem by this spill, why the dam failed, and how various organisms such as phytoplankton and fish are faring in the aftermath of the spill. The wastewater held by the dam contained substantial amounts of cyanide as it was used in the extraction of gold and silver from waste ore. In the gold mining industry, cyanide is used to separate gold from ores as it forms a complex with gold which dissolves, while the remainder of the ore remains solidified. The gold is then extracted from the solution using a variety of techniques. After gold removal, the cyanide-containing solution can either be disposed of or stored for reuse. Given the highly toxic nature of cyanide, the use of cyanide in gold mining is very controversial. This is particularly concerning in developing countries where engineering standards are not as robust and the enforcement of safety protocols is not seen as a priority by the governmental authorities. Factors that contributed to the dam failure include heavy rainfall and melting of thick snow in the period preceding the event. These extra additions of solution from rain and snow melt caused the level of water to rise in a sedimentation pond, leading to a 25-meter breach in the dam embankment, according to a report by the Worldwide Fund for Nature, also known as WWF. The Hungarian government thought it was unwise to place that amount of cyanide in close proximity to a river and that the weather, while not normal, was not unprecedented. A communication from the European Union recommended the use of suitable materials to build dams that can handle the expected load, and the provision of additional dams to provide extra storage capacity in case of unfavorable weather events. Links to documents are in the description below. The damage done to the river ecosystem by the spill is immeasurable. The Tisza River is an ecosystem that spans 5 countries in Eastern Europe, namely Ukraine, Romania, Hungary, Slovak Republic, and Serbia. The river is a spawning ground, feeding area, and nesting location for several species. There is tremendous biodiversity in this river in that there are several species of birds, fish, and other biota, and some of these species only exist in this river. The river contains several protected species, such as the Black Sea sturgeon and the southern barbel. Cyanide spills in water are always disturbing, as fish are 1,000 times more sensitive to cyanide than humans, according to several authorities. The measured concentration of cyanide in some parts of the river immediately after the spill was over 700 times the acceptable limit. 1,240 tons of fish were killed as a result of the spill, according to Hungarian officials. In the area of the river closest to the source of the spill, plankton was completely wiped out. Benthic organisms were also severely impacted by the spill, although deterioration of benthic health was already occurring due to poor water quality from previous pollution. In order to limit the damage to the ecosystem, volunteers collected dead fish, and hunters made every effort to prevent foxes and large animals from eating fish and other wildlife that passed away from cyanide poisoning. There were also economic impacts, as commercial and recreational fishing in some parts of the Tisza were temporarily banned. Also, 8 wells in the immediate vicinity of the spill in a place called Bozanta Mare were found to have high cyanide content. In addition, some local governments issued advisories asking residents to avoid using tap water given that reservoirs had high cyanide content due to the spill. In some areas, fresh water had to be transported by road to hospitals and schools. Now, let us talk about the state of the ecosystem in the aftermath of the spill. Of all the species examined, phytoplankton and zooplankton were the first to rebound. Phytoplankton and zooplankton were seen to be recovering 2 weeks after the spill in both number and species composition. Samples taken at different locations 2 and 3 weeks after the spill indicated that while number of phytoplankton was not the same as before the spill, the number of specimens was increasing at a fast rate. In some cases, the number of specimens recorded at the 3rd week after the spill ranged from 2 to 6 times the numbers measured at the 2nd week. A full recovery of phytoplankton was reported 2 years after the spill. It is thought that subsequent warm weather in March of 2000 and flooding assisted in the recovery process of phytoplankton. A link to the report is in the description below. 2 years after the spill, WWF stated in a report that none of the previously known fish in the Tisa River became extinct, and protected fish species, such as zingle, continued to exist in the river. Nevertheless, fishermen in Hungary commented 2 years after the spill that fish harvest was much lower than what it had been before the spill. Relevant research, link in the description below, in the former Federal Republic of Yugoslavia indicate that there were no significant fish population changes except for the case of the zander, a popular game fish. According to WWF, while a few mammals and birds died, most were spared from serious injury or death, partly due to the quick action of removing the dead fish from circulation by volunteers and because of the ice cover on parts of the river at the time of the spill. While some otters died, several otters relocated to channels and creeks that were not contaminated by the spill. These otters returned to the Tisa River after cyanide concentration had drastically reduced. For an assessment of long-term ecological damage from the spill, the WWF report recommends sediment analysis and long-term monitoring of fish, benthic organisms, insects, birds, and mammals such as bats and otters. I commend all the volunteers that came together to remove dying and dead fish. Doing so prevented much larger harm to the ecosystem. This incident, while deadly, serves as a reminder that our ecosystems are fragile and every effort must be made to protect and preserve them. I will place all links to the documents, reports, and articles used to make this video about the 2000 Baia Mare cyanide spill in the description below. Please like and subscribe on your way out. Thanks for watching. Cheers.